So we're doing force review for force types. So explain what a force is and how it's measured. Got that. Give me the test. It's today. Describe the difference between contact and non-contact. We'll be reviewing that again. And classify forces as contact or non-contact. So a force is a push or a pull, and the action can change the shape, size, or motion of an object. So there is a normal force. It's perpendicular to the surface, because remember we call this support. All right, so the table supporting the normal force is pointing up, perpendicular to the weight. Muscular force or applied force, person or object is pushing or pulling. Frictional force opposes the direction, so because of the surface and how rough the surface is, it can. So if we're pushing in this direction, friction is going to be pushing, impeding or slowing us down or stopping us from moving. Then we have the non-contact forces, which are called field forces, fields of magnetic fields, electrostatic. So the electrostatic is the plus, I don't know why I put a circle there, plus and minus charges. Magnetic fields are the north and south poles. And then gravity is the attractive force. It only attracts in one direction. And everything has gravity depending on its mass. More mass, more gravity. Even we have mass, so we have gravity. All right, so let's take a look at the types of forces. We have the applied force, so a person batting a ball. We have the magnetic force or field force for the north and south. The normal force, remember that's the support force that we were talking about. It's perpendicular to the surface, so this is the normal force. The tension is pulling, or you can even have tension if you're drawing. If I draw something hanging from a rope, a weight hanging from the rope, so there's tension here, attached here, so that's a tension force. All right, we have gravity. It's a field force, and we have magnetic. We got already electrical magnetic force here. That's the plus and minus charges. Spring force, air resistance because air has weight, slows us down. We're falling in a parachute, and then we have frictional force. Where are you? Frictional force between surfaces. All right. So, and to break them down into field and non-contact. So this is a non-contact force, gravity. Tension is a contact, actually touching, pulling on something. Applied forces. Normal force is that support force. Magnetic is that non-contact or field force. Air resistance is contact force. Electrical, the plus and minus charges, is non-contact. Buoyant, the way things float, is contact. And friction is opposing force to motion or contact. It has to actually feel the difference between the surfaces. All right, so all these forces, a boy is pulling and the girl is pushing, so the forces are going in this direction. So that's the applied force. Okay, there's gravity opposing that, so that's friction. Sorry, friction is opposing that, but because we have gravity that's going down, the weight of that is pushing onto the surface, and the normal or the support force is pushing up. So we have all of these involved in this pushing and pulling. All right, what force is acting opposite of the wagon? It's motion. So that's the frictional force. Frictional force is keeping, slowing this down. It could be kinetic friction, which If it's moving, it's slowing it down, makes it want to stop, so we have to keep applying the force. Or it could be, if it's not moving at all, it could be static friction. All right, so different forces here. Okay, so pushing is a contact force, applied forces, the normal force. You can see right here, the normal force is perpendicular to the surface here. So that's why we draw it this way. When this is wanting to slide down a wedge, we draw it perpendicular to the surface. Friction is opposing the force of sliding down the ramp, and weight is going straight to the earth here. So again, if it's flat, you can see the normal force here, see the weight there, and frictional force is opposite of the applied force. So if we want to draw this, okay, the normal is going to be perpendicular to the surface. So that's my normal. So that's in green. My gravity is going to be here, going straight down. So this is gravity, and this is green is the support. So this is the support, or they call the normal. Right? Okay, so we talk about how we measure this. Newtons is how we measure forces. Okay, 1 pounds is how we measure forces in the English, and newtons is how we measure forces in science. Okay. Okay, so this is a tutorial on mass versus weight. So I will read this through. So you can see from this, we have the planet Earth and some satellite and a space walk gone awry, person floating out in space. And then down here, we see an apple and then a weight. So let's click on begin here. So mass and weight are not the same thing. Mass and weight are different quantities. And when we mean by quantities, we're talking about a number. Mass is the amount of matter an object contains. The size of an object does not determine its mass. A plastic foam block does not contain as much mass as a small lead block. So here we have a plastic foam block, and there's an air gap in between. Particles are big, and a lead block, notice that the atoms are tightly packed together. If you were to look at this, like this is supposed to show us the atoms, you can see that they are spaced further apart in the plastic foam block, where the lead block, they're really close together. A bowling ball and a soccer ball are about the same size, but the bowling ball has more mass. The bowling ball contains more matter. So particles inside are closer together, where the soccer ball, they're further apart. Also, this has air inside. This is solid. So, which has more mass and atoms packed more closely together? Of course, it's the golf ball. The mass of an object contained remains constant. It does not depend on the surrounding. A 6.1 kilogram bowling ball on Earth has a 6.1 kilogram mass on the moon. The mass is the same, does not change with location. So if your mass on Earth is 100 kilograms, what's your mass on the moon? Still 100 kilograms, right? It doesn't change. Weight is relative to the force of gravity acting on it. So weight of an object can change with location. If the force of gravity increases, the weight of an object increases. If the force of gravity decreases, the weight of an object decreases. The bowling ball has a weight of 60 newtons, and we use newtons in science class. So the bigger the number of newtons, the more weight it has. We use a scale and it usually says pounds, but in science we use newtons. On the moon, that same bowling ball pulls the scale down only to 10 newtons. So the gravity is 1/6 of Earth. So the masses are the same. Nothing has changed there, but the weights are different. The bowling ball has a weight of 60 newtons on Earth. So if your weight on Earth is 100 newtons, your weight will be less on the moon because gravitational force is less. So be about 20 pounds, 20 newtons. So because of gravity, the newtons, the weight or in newtons changes. But on Jupiter, it's 152 newtons. Force of gravity on Jupiter is 2.53 times the gravity of Earth. So if you were to go to Jupiter, you would weigh 2.5 times more than you did on Earth. So the bowling ball has not changed its mass, but it changed its weight because of gravity. So comparing mass and weight. Earth, the mass 6.1, the weight 60 newtons. Moon, the mass of the bowling ball 6.1 kilograms, the weight is 10 newtons. In Jupiter, the mass is 6.1 kilograms, the weight is 152 newtons. Always remember, mass stays the same, weight can change with location. All right, as the gravity of a planet increases, the weight in newtons increases and the mass in kilograms stays the same. All right, so let's take a look at some of these objects here. All right, so if we are going to measure the mass, so I'm going to make this closer to 10 just so I can do this in my head. So if the mass is 25 kilograms, so this is going to be 250 newtons. All right, and then if we want to um, multiply the weight by 2.2, we can get the pounds. So I'm just going to do the newtons right here. So 10 kilograms times 10 newton, 10 meters per second for gravity, it's 100 newtons. 0.5 times 10 is 5 newtons. 60 times 10 is 600 newtons. 108 times 10 is 1080 newtons. So the weight of, if I got this one here, the weight of a wagon depends on its mass and what other force? Gravity. Mass and weight. Mass of an object is the amount of matter that the object possesses. Weight of an object is the force acted upon it by gravity. So, outer space, where there's no gravity, you could have 0 newtons. All right, so let's do some reflect on some friction. A skier stands on a ski slope planning his next run. What kind of friction is holding the skier in place? So this is going to be static friction. Static means stopping, right? In this particular case. Once the skier is moving down the slope, what kind of friction is he experiencing? And this is the friction of motion. Remember, this is always going to want to slow us down. And then if we stop going downhill, we'll go stop completely. But the static friction is the friction that keeps us from sliding. All right, so contact forces. So here's a view. Normal forces, the force exerted on it with a table. Tension, the force experienced by a rope this person pulls on a bucket or a hand, to bring water up a well. Friction, the resistance offered by the floor as the box slides. Applied force, this is when you push it, person is pushing. Air resistance is offered by the air when the ball falls through it. Spring force used to measure weight, so we use those. And then the non-contact force is again gravitational, field force, and magnetic force. All right, so now what we're going to do is we're going to look at the 4 fundamental forces that we talked about earlier. All right, so let's take a look. So we know that gravity is the weakest, right? The nuclear force, the weak force is stronger, but it's still pretty weak. And then the strongest is going to be the strong force, and then the electromagnetism force is going to be strong. So attractive only, and the particles and mass hold the solar system together. So that is this one, right? So responsible for beta decay, that is the nuclear weak force, holds the protons in the nucleus and the neutrons. That is the strong force. It's the strongest, but it's really a short range because it only acts within the nucleus, keeps the protons together. They want to repel each other. And the charge, particles positive attracts negative, and this is the electromagnetism. So short range for the weak and the strong force, because the weak only works with the in the atom in the nucleus, trying to keep that helps with the, as we said, the beta decay and nuclear fission. But the electromagnetism and gravity have an infinite force. All right. All right, so time to climb. And then I'll let you guys do this on your own here. I'm going to stop sharing here. And we're going to end the meeting.